Hello and welcome to a video on the mid-segment of a triangle, otherwise known as the midpoint connector. And the midpoint connector pretty much describes what it actually is. It's just a segment that connects the midpoint of one side of a triangle to the midpoint of another. So if you're looking at a triangle and P is the midpoint of the segment LM and Q is the midpoint of segment MN, then PQ is the midsegment or midpoint connector. Okay, so here's another diagram with pretty much the same thing. Here R is the midpoint, S is the midpoint, and so RS is the midsegment of the triangle. One of the midsegments. Now there's three midsegments in every triangle, and here's one more diagram that shows all three midsegments of a triangle. And notice what happens when you create all three midsegments, when you connect all of them. And these are the midsegments right here, the lines that connect, or the segments that connect the midpoints. You form a triangle on the inside, and you also form four triangles on the outside, or three triangles on the outside, so a total of four triangles are formed when you draw all three of the midsegment or midpoint connectors. We're going to look at midsegments from the perspective on the coordinate plane. So let's go back up here to a couple of triangles. There's actually 6 triangles in this diagram. We're going to just focus on 2 of them. So what I did was and you can draw this on any graph paper. It doesn't have to be on this particular paper. But what I did was I put a corner of each of 3 different triangles at the origin. I placed a coordinate plane. So for this first triangle, let's just call this triangle A so we know what we're talking about. This triangle over here, one of the vertices is at 0, 0. If I count, this vertex up here is at 2, 1, 2, 3, 4, 5, 6. So this is at 2, 6. And then the other vertex over here is at 1, 2, 3, 4, 5, 6, 7, 0. So this is at 7, 0. So we're going to focus on that triangle first. And what we're going to do is we're going to find a midsegment. Okay, so we're going to find the midsegment. And let's just give this triangle some names. Let's give this, let's not name it A because I already called it triangle A. Let's call this PQR. So this point here will be P, this point up here will be Q, and this point down here will be R. And that X just indicates that this is the X-axis. That's all the X means. Okay, so this is triangle PQR. So what we're going to do is we're going to find the midpoint of PQ, and then the midpoint of QR, and we're going to plot them, and then we're going to see if we can draw the midpoint connector. All right, so the midpoint, so for triangle A, so this is for triangle A, we're going to start out with the midpoint of PQ. Okay, so PQ has a midpoint. Remember, the midpoint is the average of the x's, so it'd be 0 plus 2 over 2. And then the average of the y's, so it'd be 0 plus 6 over 2. And that midpoint would be 2 over 2, which is 1, and 6 over 2, which is 3. So the midpoint from PQ is 1, 3. So over 1, up 3. It's just what it looks like right there. Let's draw our midpoint, our midsegment in green. All right, let's find the midpoint of QR now. All right, now it looks like it's right about here, but let's just see where it is. So the midpoint of QR let's see. So we've got QR, so we've got the average of the x's, so 2, 7, so that would be 2 plus 7 over 2, and then the average of the y's, which is 6 plus 0 over 2, and 9 over 2 is 4.5, and 6 over 2 is 3, so we're going to go 4.53 for our second midsegment. So we go over 1, 2, 3, 4, 4.5, up 1, 2, 3, and it's right there. So here's our first midsegment. There it is. All right. Now we're going to continue the fun here, and we're going to find the length of the midsegment. So let's write down the ordered pairs here. This is 1, 3, and this is 4.5 and 3. Okay, so now we want to find the length of that. Well, because it's parallel to the x-axis, we can actually just count to get the length. This has a length of 3.5. It just goes from 1 to 4.5, so it has a length of 3.5. Okay? This one below, PR, has a length of 7, right? What do you notice? Well, let's hold off before we make our observation. They're both horizontal, and the lengths are related. Well, we're going to jump over now to triangle B over here, and we're going to do the same thing. All right, so let's try the same thing with triangle B. I'll tell you which one to find. Okay, we'll work on this together, but we're going to just practice finding our midpoints. So why don't we pick, I'm going to move that B out of the way, and because it's right where the midsegment's going to intersect, so I'm just going to put it up here somewhere. Why don't we call this triangle RST? So we'll call this R, we'll call this S, and we'll call this T. All right, let's get the coordinates of T. So this is just the y-axis. That's what the y is there for. If you don't like it, let's just get rid of it. It's kind of in the way. All right, let's find the length, the coordinates of T. Now T looks like it's at 0, 0, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is at 0, 10. Let's get the coordinates of S. So the coordinates of S are at 1, 2, 3, 4, 5, 6, 0. And let's go ahead and find the midpoint of each of these. Well, this is pretty easy to find the midpoints this time, because in the middle of 0 and 6 is 3. So we know that this is 3, 0. And the midpoint from 0 to 10 would be at 5. So up 1, 2, 3, 4, 5, right there. And that would be at 0, 5. And let's make our midsegment. So let's connect these two with the straightest line that we can get without a ruler. You can use a ruler if you want. All right, now let's compare. This time the distance is going to be a little bit more work. It usually works out so that if the midpoint is easy, then the distance is hard. And over here, we saw where the midpoint was a little bit more work, but the distance was really easy. So it's usually one or the other. Sometimes both of them involve more work. So let's call this midsegment how about DE? DE. Okay, we'll call the midsegment DE, and we're going to find the length of DE. So the length of DE is the square root of the distance between the x's, which is 3 minus 0, plus the distance in the y's, which is 0 minus 5. And that gives us the square root of 3 squared, which is 9. Now, negative 5 squared is 25, so this is plus. So plus 25, or the square root of 34. Now, let's find the length of ST. That's the third side that we didn't even use yet. We haven't done anything with segment ST yet. So ST is equal to, let's see, the distance in the x's is from 6 to 0. So the square root of 6 minus 0 squared, plus the difference in the y's is 0 minus 10 squared. And that is the square root of 6 squared is 36. Negative 10 squared is plus 10. Oops, plus 100. And that is the square root of 136. Now there's two things that we can do here. One of them is we can simplify this radical. And the other one is we can put these in a calculator and estimate them. Let's simplify this one first. This happens to be divisible by 136 happens to be divisible by 4. In other words, we can rewrite this as the square root of 4 times the square root of 136 divided by 4, which is 34. That number looks a little familiar. So this is 2 times the square root of 34. Well, let's look at these two. Let's look at the length of the midsegment. That is the square root of 34. And the length of the segment, the third side of the triangle, that's 2 times the square root of 34. In fact, it's twice as long. It's twice as long. Okay? So here, the segment that was the third side was 7, and the midsegment was 3.5, also twice as long. So this is an important property of the midsegment, that the midsegment is always half the length of what we call the third side, because the midsegment is formed by 2 of the sides, and it's going to be half the length of the third side. So rule number 1 is that the midsegment, here, let's write this down here. 1 is that the midsegment is half the length of the third side. Ready to practice something else? Let's practice slope. Well, let's first look at these first two. Now, these first two in triangle A, the slope of both of these, the slope of the midsegment and the slope of side PR, they're both 0, right? They're horizontal lines, so the slopes are 0. So these two are parallel to each other. So the midsegment is parallel to the third side in that triangle. I wonder if that will be true of triangle B as well. It may be. It looks like it could be, but we're only going to find out if we actually calculate it. So let's find the slope of DE. So let's find the slope of DE. And remember that the slope is just the change in y over the change in x. So I'm going to go 0 minus 5, that's the change in y, over 3 minus 0. 3 minus 0 is the change in x. So I get negative 5 over 3. Negative 5 over positive 3. I don't have to reduce that any. That's it. Negative 5 over 3. What about the slope of TS? I wonder if that's also negative 5 over 3. Let's check it out. Slope of TS is equal to 0 minus 10. That's the change in the y. Over 6 minus 0. That's a 6. 6 minus 0, that's the change in x. This is negative 10 over 6, and that reduces to negative 5 over 3. So these are also parallel. That gives us our second rule about midsegments, and that is, number 2, the midsegment is parallel to the third side. Okay, there you go. 2 amazing properties of midsegments, and this is going to create some interesting stuff down here, because if each of these is half the length of the third side, we're going to end up seeing that there's not only 4 triangles in here, but those 4 triangles are absolutely 100% congruent and identical to each other. We're going to see that a little later, but right now just kind of notice it looks like that's true, and we're going to see later why it is true. All right, I hope you found this video helpful. Main thing to pick up from this is that 2 properties of midsegments are going to allow us to write some equations, and we'll look at some examples in the next video.